Hello students, this is Dr. A.S. Sayyed. I welcome you all for the course on finite element method in civil engineering. Our today's topic is shape functions of bar element using Lagrange's interpolation function. So in this class, we will see that how to apply Lagrange's interpolation function to determine shape functions for bar element in natural coordinate system. Okay, so as an example, if you consider the first element is two noded bar element. Okay, so this is the bar element considered. We know that in natural coordinate system origin is always assumed at the center of element, and that's why at center origin is assumed. Since bar is a one-dimensional element, it is having only xy coordinate, okay, which is positive towards right, and xy coordinate is negative towards left, right? These are the sign conventions. So since at origin xy equal to 0, we know that maximum ordinate of natural coordinate is +1 and minimum coordinate is -1. So since node number 2 is on the right of origin, the coordinate of that node number 2 is xy equal to +1, that is +1, and since node number 1 is on the left of origin, xy is equal to -1. So these are the natural coordinates of two nodes. Node number 1 xy equal to -1, node number 2 xy equal to +1. Okay, now since we are using Lagrange's interpolation function, first we have to apply how this function is working, how it works to determine the shape functions. So Lagrange has defined polynomial to find out the shape functions. So for one-dimensional element, that polynomial is written like this. Okay, now if you understand both the terms, left hand side and right hand side term carefully, left hand side term represent nk, where n stands for shape functions and k stands for the node number at which you are writing the shape function. It means if you are writing shape function for node number 1, this k will be equal to 1, and if you are writing shape function for node number 2, k will be equal to 2. Okay, like this. If you are writing shape function n1, then k is equal to 1, and if you are writing shape function 2 for node number 2, that is n2, then k will be equal to 2. Okay, now on the right hand side, okay, summation of xy minus xy m divided by xy k minus xy m. Okay, so xy minus xy m, now m stands for here in these two terms, m represent the remaining node numbers. Okay, for example, when you are writing n1, if k equal to 1, the remaining node here is node number 2, so m will be equal to 2. Okay, and if you are writing shape function n2 where k is equal to 2, then remaining node in this two noded bar element is 1, so m will be equal to 1. Okay, so this is the meaning of k and m which is used. This xy represent the xy coordinate of that particular node. Why this summation sign is included, that we will discuss in the next example when we consider the three noded bar element. Summation represent that if you are considering the kth node and remaining nodes are more than 1. For example, if it is a three noded bar element, when we are considering n1, then remaining nodes are n2, node number 2 and node number 3. So when remaining nodes are more than 1, then we have to take summation of that, and that's why this summation sign is included, that you will better understand when we will take the next example of three noded bar element. Okay, now we will apply this polynomial one by one to find out the shape function. Now shape function at node number 1. Okay, so if you are writing shape function for node number 1, we know that k will be equal to 1 and m will be equal to 2. Remaining node is m, that is second node number 2. So n1 is equal to, here k equal to 1, xy minus xy m is equal to, so xy minus xy2 divided by xy1, here it is k, okay, xy1 minus xi2. So xi minus xi coordinate of remaining node, that is xi2, divided by xi coordinate of that node for which we are writing shape function, that is node number 1, minus xi2. Okay, so this is the polynomial xi minus xi2 divided by xi1 minus xi2. So these two represent the value of m and this one represent the value of k. Okay, now if you substitute the coordinate xi minus xi2 means xi coordinate of node number 2, xi coordinate of node number 2 is plus 1. Okay, xi coordinate of node number 2 is plus 1. So xi minus, and instead of xi2 we will use this plus 1. Okay, this minus sign is of that polynomial. Okay, it is plus 1 coordinate of xi2. Similarly, divided by, now divided by, it is xi1. Xi1 means xi coordinate of node number 1. So what is xi coordinate of node number 1? It is minus 1. So here it is minus 1. Then this minus sign is as it is minus. What is xi2 again? xi2 is plus 1. Xi coordinate of node number 2 is plus 1. So it is plus 1. Right? Like this you have to substitute the xi coordinate of node number 1 and node number 2. Okay. Now if you simplify this, numerator and denominator, the denominator is minus 1 minus 1, it become minus 2. So if you take minus sign outside here and if you take minus sign common from numerator, it will be like this, minus 1 minus xi and then minus 2. So this minus minus will get cancelled. The answer will be 1 minus xi upon 2. Okay. Similarly, if you want to write down shape function at node number 2, then k will be equal to 2 and m is equal to remaining node is node number 1. So m will be equal to 1. Okay. So n2 is equal to xi minus, now it is xi1 because m is equal to 1, divided by xi2 because k is equal to 2, divided by xi2 minus xi1. Okay. So again if you substitute the coordinates of node number 1 and node number 2, xi1 means minus 1. So put here minus 1. So this xi minus this minus 1, it becomes xi plus 1. Right? Now divided by xi2, xi2 is plus 1. Okay, this is plus 1. Minus this minus, now what is xi1? Xi1 is equal to again minus 1. So it is minus 1. So this 1 minus minus 1 becomes 1 plus 1. Okay. So what is final value of n2? n2 is equal to 1 plus xi divided by 2. Okay. 1 plus xi divided by 2. This is value of shape function. So since it is a two noded bar element, it is having only two shape function, n1 and n2. So n1 is equal to 1 minus xi upon 2 and n2 is equal to 1 plus xi upon 2 using this Lagrange's polynomial function or interpolation function. Similarly, if you apply the Lagrange's interpolation function for three noded bar element, those three noded bar element will be like this: node number 1 on the left, node number 2 at the center, node number 3 towards right. Okay, now since we are using natural coordinate system, origin is assumed at the center O where xi equal to 0. So xi coordinate of node number 2, origin and node number 2 is overlapping. Okay, coincides. Origin and node number 2 coincides. So xi equal to 0, it is xi coordinate of node number 2. Xi equal to minus 1 is a xi coordinate of node number 1 and xi equal to plus 1 is a xi coordinate of node number 3. Now if you apply the Lagrange's polynomial here, okay, now understand, when you are applying, if you want to find out shape function at node number 1, so k is equal to 1, k is equal to 1, but m is equal to what? Remaining nodes. Now there are two remaining nodes. M is equal to, if you are writing n1, k is equal to 1. Now m is equal to, first we have to take 2 and then we have to take 3. that is node number 2 and node number 3 are remaining nodes when you are writing shape function for node number 1 or k equal to 1. Therefore, n1 is equal to, see here, first we have written or applied the polynomial for k equal to 1 and m equal to 2. Okay, k equal to 1 and m equal to 2. So xi minus xi2, that is remaining node, divided by xi1 minus xi2. This is m equal to 2, first k equal to 1. Then multiply by, this represent that, if you remember that summation sign initially in the previous slide, summation sign represent, now since there are more than 2 remaining nodes, node number 2 and 3, we have to again apply the polynomial for node number 3. So xi minus xi3 divided by, k will be same, k equal to 1, but m is changed now, m is equal to 3 here. So first is for m equal to 2 and second is for m equal to 3, and in both the cases k is equal to 1. So xi minus xi2 upon xi1 minus xi2 into xi minus xi3 divided by xi1 minus xi3. Okay, now if you substitute the coordinates carefully, now xi minus xi2, what is xi2? Xi2 is equal to 0. This is xi2, this is xi3, this is xi1. Okay, so xi2 is equal to 0 here, divided by xi1. This xi1 is equal to minus 1, so it is minus 1 minus again xi2, so it is 0, into now second ratio xi minus xi3. Xi3 is equal to plus 1. Okay, here xi3 equal to plus 1. So xi minus plus 1, this is xi3, divided by xi1. Xi1 equal to what? Xi1 equal to minus 1 minus xi3 is equal to again plus 1. So if you simplify this now, if you simplify, the xi minus 0 is equal to xi and xi minus 1 is the next bracket. On the denominator, minus 1 minus 0 is minus 1 into minus 1 is minus 2. Minus 2 into minus 1, answer is plus 2. Okay, so this is n1. Similarly now, if you want to find out shape function for node number 2, so it will be like this. Okay, node number 2, if you are writing, it means k is equal to 2 and m is equal to now 1 by 1. First is 1 and then m is equal to 3. Okay, 2 values of m. So first we will write down for k equal to 2 and m equal to 1, first ratio xi minus xi1 divided by xi2 minus xi1. So here m is taken as a 1 and k is equal to 2. And next ratio we will write for k equal to 2 and m equal to 3. So xi minus xi3 upon xi2 minus xi3. So m equal to 3 and k equal to 2. Okay. Again, if you substitute the values of coordinates like this, xi1 equal to minus 1, xi2 equal to 0 and xi3 equal to plus 1. If you substitute these values here, xi1 is equal to minus 1, xi3 is equal to plus 1, then xi2 is equal to 0 and xi1 is equal to minus 1. So this minus and minus become plus here. Similarly on the numerator, minus become plus. Okay, please understand, this is xi minus 1 and here it is 0 minus 1. So it becomes 0 plus 1 and numerator becomes xi plus 1. Similarly in the second ratio, xi minus, since xi3 is plus 1, xi minus it is xi3 and xi2 which is 0 minus xi3 is 1. Okay, like this you have to write down the coordinates. Now if you simplify this, you will get the shape function for node number 2. Xi plus 1 means 1 plus xi. Xi minus 1 is, if you take minus sign outside, it becomes 1 minus xi and there is a minus sign, and divided by 2, this 0 plus 1 is 1 and into 0 minus 1 is minus 1. So denominator will be minus 1 and this minus will get cancelled. The answer is 1 plus xi into 1 minus xi. Okay, that we can also write down like a plus b factors, a plus b and a minus b factors, so it will be equal to 1 minus xi square, that is a square minus b square. So this shape function we can also write down like this, 1 minus xi square. Okay, similarly if you want to write down shape function at node number 3, node number 3 means k is equal to 3 and m is equal to 1 and then 2. Okay, m is equal to 1 and then 2. So 1 by 1 first we have to apply k equal to 3 and m equal to 1. Okay, so xi minus, this is xi 3. Okay, sorry, xi 2, right, sorry. This is first ratio E for k equal to 3 and m equal to 2. Okay, m equal to 2. So xi minus xi 2 upon xi 3 minus xi 2. And second ratio for k equal to 3 and m equal to 1. Right? So xi minus xi 1 upon xi 3 minus xi 1. Okay, right? If you substitute the coordinates now for xi 2, which is equal to 0 here, xi 2 equal to 0 here, xi 3 is equal to plus 1 here, xi 3 equal to plus 1 here, then xi 1 is equal to minus 1, so it is xi minus 1, it becomes xi plus 1, and denominator xi 3 minus, xi 3 is 1 minus xi 1 equal to minus 1, so 1 minus minus 1, 1 plus 1 here, right? Like this you have to substitute the values of coordinates of nodes. You will get the third shape function xi n3 is equal to xi into 1 plus xi divided by 2. Okay, so there are 3 shape functions for 3 noded bar element because there are 3 nodes. There are 2 shape functions for 2 noded bar element because there are 2 nodes. Okay, if you want we can plot the variation of this shape function also. So for 2 noded bar element there are 2 shape functions. From this we can also check one of the again important property of shape function, that sum of shape function is always equal to unity. So if you add n1 plus n2 equal to, if you look at 1 minus xi upon 2 and plus 1 plus xi upon 2, if you look at these shape functions, if you add the shape function, this minus xi plus xi will get cancelled, 1 plus 1 is equal to 2 divided by this 2 and answer will be equal to 1. So this can prove that sum of shape function is always unity. Okay, now if you want you can plot the variation of shape function. See here, if you take n1 is equal to 1 at node number 1, so if you give a rise of unit here and n2 is equal to 0, so you go to 0 at node number 2. This is variation of shape function 1. Okay, this is variation of shape function 1. Similarly in the same figure, if you want to plot the variation of shape function 2, n2 is equal to 1 at node number 2 here, n2 is equal to 1 and n1 is equal to 0 at node number 2, n1 is equal to 0. So here it is unity and then it is 0 at node number 1. Okay, so like this you can plot the variation of both the shape function in a single figure itself. Similarly you can plot the shape functions of 3 noded bar element. These are the 3 shape functions just we have derived. A variation of this shape function will be xi into xi, so it is xi square, second order. So variation will be second order. So first n1 is equal to 1 here, n1 is equal to 1, right, at node number 1, n1 is equal to 1 and other two n2 and n3 will be 0. So it is a second degree curve with n2 is 0 and then it is goes to down to reference line and again n3 is equal to 0. So this is variation of n1. Similarly n2, so it is unity at node number 2, right, it is unity at node number 2 and then it is 0 at node number 1 and 0 at node number 3. So it is a parabolic curve like this. Similarly n3, if you plot n3 is equal to 1 at node number 3. So here n3 is equal to 1, give the vertical rise of unity at node number 3. Then n2 and n1 are 0. So it is a second degree curve which passing through n2 which is 0 and again down to reference line and n1 it is 0. So this is variation of shape functions for 3-noded bar element. Okay, and like this we can determine shape functions of 2-noded or 3-noded bar element using Lagrange's interpolation function. Okay, so please understand how to apply the polynomial of Lagrange's to find out the shape functions. So this is the polynomial equation xi minus xi m upon xi k minus xi m. Okay, I hope all of you understand. In the next class, we will apply this Lagrange's interpolation function to find out shape functions of rectangular elements. Okay, thank you very much.